Thanks, Rohit, for walking through the questions. And with that, we have our next speaker already set in his purple vibey room, very very cool looking room. Hey Marino, Marino, thanks for joining and giving us your time and talk that you're presenting. Marino is a developer advocate at Solo.io, which is also where Rohit works. And with that, Marino, I'll hand you over the stage, and you can take some time to actually introduce yourself. Thanks again,
Yeah.
Maran.
Thank you so much. Thank you so much. I'll go ahead and share my screen. Let me know when y'all can see that.
Yeah, we can see that.
Perfect. Perfect. Well, this is really exciting because I love doing conferences. I love just doing things for the community. And this is just fantastic, having some conversations around what goes on in the world of DevOps. And it's interesting to see what, like, all of these different perspectives that are around. I have obviously one to offer, and that really comes and stems from the fact that I've spent a great number of years working in the world of network engineering. Network engineering is a pretty large domain, and it covers a variety of different areas. And what's interesting is and more specifically, I've seen a lot of transition towards the world of DevOps, and I've seen this. I've seen consolidation of how network engineering works with DevOps, and so this is where I decided, let's talk about how network engineering went DevOopsie. So my name is Marino Wijay. I am a developer advocate. I don't know why it didn't move. There we go. I am a developer advocate as well. Along with Rohit, I work at Solo.io. And for those that don't know what Solo does, it's around application networking, specifically around things to do with containers, microservices that run on top of Kubernetes, to provide like a full stack network experience, both from a service mesh perspective as well as a container networking perspective. So that being said, I spent a lot of time just talking around the community around what networking does and what it means for DevOps today, as well as, I'll stream some stuff on occasion. So I'll hop on Twitch and really talk about this stuff in depth. So the last time I did this, last Friday, I was basically trying to get BGP, or the Border Gateway Protocol, up and running between two clusters, just to see how networks were being learned. Now, I will say this presentation is not about how to use a YAML file to configure your network. I'll talk about elements of that. This is not a highly technical talk, to be honest. It's really more about giving you a story and then forming a pathway for you to figure out how you can get there. So we'll start off with something very controversial: service mesh as a VPN. Now, if you've ever played with, let's say, network devices, if you've ever played with firewalls, there was this functionality or feature where you could actually deploy an IPsec VPN tunnel to between two networks, or between two endpoints, or two, let's say, office locations. And what that would allow you to do was basically create a pathway of communication, so that site A or office A can talk to office B. And we're talking about either end users or servers that can communicate across the public internet, however, still being encrypted all the way throughout. So if anyone were to try and sniff that traffic and capture it and break it down, they wouldn't really know what was inside of the payload, because it was all encrypted anyways. Now, one of the reasons why I say this, service mesh as a VPN, is because there is this concept of how things have gone cyclical, how things have gone almost full circle, in my opinion. But what's really interesting is, while the underlying capabilities and technologies of networking have gone through this circle, it just looks different. So when I think about service mesh being a VPN, there are key things about a VPN that make this very, very much true. And what that is look, with a service mesh, I'm encrypting traffic between two endpoints, two containers. I'm also, making sure that they're authorized and they're authenticated. This is very much what a VPN does. The second thing that I would do is traffic engineer, because I need to I need to be able to determine my path around the network to find the destination I'm going to. which is exactly what a VPN will offer. It offers some level of routing. And then the very last thing is you want to understand at a very high level what performance metrics might come your way to better understand if there might be latency between the way your application functions between these two endpoints. And to a degree, a VPN will normally tell you this, not always. And the reason why that is because of where it sits in the stack. It's actually a lot lower in what we would call the OSI model. Now, that being said, right, there are a lot of similarities between what a service mesh does for thousands of microservices versus what a VPN does. But what it really comes down to is, you know, we're talking about a technology that's 10 plus years old, which is still used today. And we're talking about a technology that is highly utilized in a lot of production environments to provide a lot of different features. Now, a lot of this stems from this concept of your infrastructure needing to die. Now, it's not like I'm literally going to go there and tear down your infrastructure, but it's really around this concept of distributed infrastructure, immutable infrastructure, and ephemeral infrastructure. And the reason why I bring this up is because this is the patterns that have kind of stemmed towards networking. This is what networking has kind of gravitated towards. And I'll talk a little bit more about that as I go further along. But this idea of our network can't be really easily changed, so we should be able to easily throw it away and spin up one very quickly, while also allowing it to be highly distributed, which we actually need it to be anyways, is where this concept lives. Now, this concept was actually borrowed from one of my peers, Timothy Mamo, who gave this talk at DevOps Days Seattle around infrastructure needing to die. So it's a very interesting concept because that's where networking has gone. Network technologies have effectively become distributed. There are concepts of applications that use the network, and because of that, you know, the network can't be immutable or ephemeral at times. So we have to, you know, work around those constraints. That being said, for me, my journey really started off with building out my home like wireless network. So I don't know how many of you have actually you know, dug into this, but years and years ago, we started with 802.11b, which was pretty expensive. And I'm talking about like back in 2004, where, you know, we were basically trying to get connectivity around our house. I needed, you know, connectivity to my room so I can play games and just, you know, do research without having to go all the way to the basement. And wireless networks were a thing. So I built our wireless network. I went to the computer store that was pretty close by, bought a wireless router, a wireless PCI card, got it up and running after, you know, moving things around, because at the time, signal wasn't the best, right? You have to strategically place your wireless router in a particular location to maximize on signal. And there were a lot of tools that followed to kind of determine your heat map, to determine where best to place your wireless router. That being said, after I, you know, started doing this, word got around, family's like, hey, you know, can you set up a wireless network for me? And, you know, before you know it, I was setting up wireless networks. The funny thing is, it was really plug and pray. So you would hope that everything would just work. And so I started at the bottom of the OSI layer, and now we are here. And so I want you to just, you know, take a moment to imagine an OSI model. Actually, I'm not going to do that to you. Here is an actual OSI model that I've used as a way to establish a pillar of networking, right? Like I look at this OSI model and say, look, if I am trying to move traffic around, I have to look up the stack and understand how traffic is moving through this stack. So I specifically started here at the physical layer, and we're talking about devices and cables. And I spent some time in a few job roles that I've had where I was literally just racking and stacking switches and cabling them up. And quite honestly, you know, when you think about that, when you think about what goes on, I mean, there's so much more intelligence that goes on behind the scenes under that specific switch or under that router. There's a lot of intelligence, there's a lot of configuration. I didn't know that, right? I actually had to go dig into understand that a little bit more. And it was because my supervisor suggested that I start looking into network certifications. You might have heard of the Network Plus, and and maybe a particular vendor's massive networking certification path that they offered years ago. They still kind of do. They've changed it around. But that's what got me into understanding that there was a lot more than just the physical layer, right? There was so much going on at the data link layer. So we were configuring VLANs and understanding where MAC addresses were being learned and why we were learning about MAC addresses in many switches. And that was all because of trunk ports and whatnot. And then we also I learned that within a given network, a lot of entities can communicate, but when we have to go between networks, we need some sort of intermediary device to get us there. And so routing became very critical in how I understood it. And what you'll start to realize is if you're looking along the left-hand side, we're climbing up the stack. We're climbing up the stack. While also, if you look at the right-hand side, you're seeing how these technologies look today. So at the physical layer, years ago, we were actually dealing with physical routers and switches, and we still do. The interesting thing, though, is we can transpose a lot of that to x86 platforms, or even at some point in time, ARM platforms, because maybe we're looking for cost-effective approaches. And you might see ARM show up at the edge quite often. Now, I'm bringing this up because at this point, hardware is almost irrelevant. As long as it can give you enough CPU and memory, and you've got enough network ports on that server, you can treat it as a network if you want. You can layer a network on top. And this is where technologies like container networking interfaces come in, where software-defined networking comes in, et cetera. I wasn't there yet, by the way. We're still in this part of my journey where I'm still playing with things in a very undistributed nature. So I'm going to every single unit and configuring it. But I'm understanding what goes on. I'm moving packets around. That's okay. But what's interesting is as you climb up the stack, right, you start to see that there is much more intelligence to be gained. There's much more flexibility in what we can do. There's a lot more data we can make decisions on. And that has driven technologies like web application firewalls and proxies, as well as API gateways, which were a thing up until Service Mesh showed up and started really, taking over the show because of what it could do. Now, for my journey, right, I mentioned a little bit about certifications and what I was after, and I effectively was after chasing the certification dragon. I effectively wanted to get as certified as I possibly could to understand a lot of things about networking. And that worked out for a bit, but I started to realize that, yeah, you could read a bunch of books and learn a bunch of things and play in a lab, but unless you're actually playing with this live, in person, in production environments, you're never going to feel the burn of when a network goes out and you literally have to, figure out, how to bring that network back online. So for my journey, I basically started working with campus networks where I would just deploy routers and switches, and I gravitated towards data center networks where we were doing some very interesting things to make sure that packets move very quickly in the data center. And to achieve that, you kind of have to limit your broadcast domains or your VLANs and use a lot more routing, because in routing, things are a lot more efficient. You can use multiple paths. You have less likelihood of network loops and whatnot. But we're not going there right now. It's about the idea that a lot of these technologies kind of come together and work together to create a platform where you can run your application on top of. This network is highly critical. And what I started to see is when it came to storage networks, it always still depended on the network itself and how it was configured. And this is why things like jumbo frames, or let's be more specific, MTU 9000, or anything greater than 1500 became very critical in the data center to optimize, how packets moved around. But, we're talking about low level stuff here. This is not really about where I was supposed to go. I wasn't supposed to get deeper and deeper into this world. I started to realize that, there was so much complexity in the world of networking that even people who own networks were starting to create their own technical debt the moment software-defined networking came into the mix. So with software-defined networking in the mix now, we're automating a lot of the networking. We're automating a lot of the VLANing. We're automating as much as we possibly can and removing any sort of toil and possibility for error with, potentially mistyping something. But the one thing that, really stuck out that wasn't available to me 10 years ago was Git. The technology of Git, like literally version control wasn't a thing in the world of networking. And why this was important was because, if I'm trying to create a configuration and I want other people to look at it, if I store it locally on my device, how are people supposed to see what I'm doing? This is the exact same challenge that we tried to solve with development, and we have with version control, source control. But that being said, networking could have taken a lot of advantage of it, primarily because we're storing configuration and state. And a week from now, that configuration needs to change, but we also need to go back and check. We also need to allow people to collaborate. We also need to create a centralized repository where our configuration lives, so we can take advantage down the line of principles like GitOps. So this is where we started to see, and I started to see a lot more gravitation towards net DevOps or networking DevOps, where Python was the forefront of how you built your networks and automated them. Ansible was the way you can configure your networks using Git and desired state if you want to, and even take advantage of abstraction platforms like Napalm, which effectively abstracted your network devices and served up APIs for them so that you could effectively use YAML to deploy your networking. So what's funny is, while the real networking world was building the stuff on the side to actually become more automated and aligned to DevOps, there were other things that were going on where we wanted to remove that complexity, where the networking world also wanted to say, hey, let me simplify this for you. So this notion of SD-WAN came about and basically took all of the elements of version control, automation, and just loaded this up into a UI and a database. While this is cool, this is not the way we wanted to do DevOps, because it removed our ability to be very tunable, right? I want to tune things. I want to be able to configure them to my own desires. And as a follow-on, right, as I mentioned previously, there was no Git. Today there is Git. Git is important because it allows us to collaborate. It allows us to make changes and revert back to them. If I had all my configurations on my laptop, and if my laptop died and I was not able to recover any of those configurations, what am I doing? I'm rebuilding everything from scratch. This is every programmer's dilemma. And it's not a dilemma anymore, because now you're going to store it in a version control system. But had we had Git back then, network changes would have been much more seamless. We would have had less outages altogether. We would have been able to iterate very quickly on our network devices whenever we had a change come in. Change controls for those that work in the ops world would have been processed a lot more quickly. So these particular challenges could have been solved if Git was something that was made available to network engineers. It is available to you if you are a network engineer today. That being said, Kubernetes enters the chat. And because it enters the chat, this throws networking just all over the place because it becomes super highly complex. In fact, there is a diagram, or an image out there, if you go look it up, Kubernetes networking, you'll see this like very, squiggly line, bunch of squiggly lines inside of this Kubernetes thing, which is true. Kubernetes networking is not easy because what happens is now you introduce some very complex topics. You introduce this concept of network namespaces, which then turns into container networking interfaces. But then you realize that container networking interfaces can't seem to provide that routing intelligence at layer 7, because a container networking interface is a network switch. It does layer 2, 3, and 4, and that's all it cares about. But then we also have now service meshes and API gateways. We can use these two to bring in that intelligence at layer 7, like I previously talked about. And you can forget about the fact that you already have an investment in SD-WAN, because at the end of the day, depending on how you operate your network, SD-WAN might be a thing. I'm not here to talk about SD-WAN. I'm here to talk about the fact that you just need a network, and then you can build on top of it. You need compute resources. You can build on top of it. But everything that you see in this list right here, network namespaces, CNIs, service meshes, whatever, those are logical constructs that are YAML, that can go into YAML, which means, actually, this is out of order, which means that, okay, I should have edited this a little bit, but this simply means that technologies like Istio, CTL, proxy config, and show IP route will produce very similar information to a network engineer. Why this is familiar to a network engineer is primarily because when you think about what you're looking for when you're troubleshooting a network, you're trying to troubleshoot how to get to that destination. So you will use tools like traceroute to figure out whether or not you can get there. You'll use tools like ping, and then you'll go a little bit more advanced to find out if you're even learning about those routes. Now, that top command there, istoctl proxy config route, is very similar in the output that it produces to show IP route, because it is telling you where these destinations are and how to get to them. The visual of what you see looks a little bit different, but if you can shift your mindset a little bit to understand that you're still looking for the same things as a network engineer, then it's okay if there is BGP in your YAML. It's okay if there is TCP configuration in your YAML. It's okay if you're configuring policy for layer 3, 4 CIDR information with ports in your YAML. And why I say that is because you will find your networking configuration in your YAML, per my previous point. And why this becomes important is, as you as a network engineer, or even a developer, or a DevOps engineer or practitioner for that matter, for those specific details, right, you're actually taking those in, dropping them into YAML, feeding that YAML into Git, and then telling Kubernetes or the API to take that configuration and apply it, and then create your network on the fly just in time. Because it's critical that we align just in time for when we build our applications. We want the network to be there, but we also don't want it to be there when it doesn't need to be there. And this is why why network engineering has gone DevOopsie. Now, that being said, right, Service Mesh is a VPN. In a lot of different ways, it is also not a VPN, but it is a network layer that is highly utilized and leveraged inside of a lot of production Kubernetes or container environments. Through my lens, as a former network engineer, we've actually gone full circle. I'm trying to become a developer to a degree. I'm a developer advocate, even though I don't develop code or develop applications. But the thing to consider here is, you, as a network engineer, shift your mindset a little bit to understand why developers do what they do. And that's what I'm trying to do. The very cool thing is, networking and applications get to move swiftly together because of where we've gone with these technologies, because we've built on top of CNIs and service meshes. So, to a network engineer, this is a technology we've probably needed forever. Service mesh specifically, and even CNIs working together. To DevOps engineers or to developers, it's funny, you actually solved this problem for network engineers, and we just didn't really know about it until we started digging into what Kubernetes and networking was doing. So it's very interesting to see how, from a network engineering perspective, the foundational elements have gone full circle. So, I left this slide blank intentionally because I really am here to say that you as a developer, you as a DevOps engineer, or even a network engineer, you have a place in the world of DevOps. And you can take a lot of your networking skills, you can go out and learn networking skills, and they become a Swiss Army knife for you when you are out there building out applications or infrastructure. So what I will leave you with is that if you are looking to get started, either on the DevOps side to learn networking, or either on the networking side to learn DevOps, here are a number of resources for you. The very first one I would recommend is Anaisa's 100 Days of Kubernetes course, primarily because she covers everything from soup to nuts, all the way from Kubernetes, starting off as you knew nothing, because she started off as she didn't know anything, and she built off a lot of knowledge that way. Highly recommend you go look this up. She has a brilliant YouTube course and a channel that you can go, scope out and see what's going on and learn a lot. The second thing I recommend you do, check out Kunal's computer networking course, because it provides you a different mindset as to how to approach computer networking, and then understand networking technologies and how they relate to DevOps. And then further to that, you can also take the path of 90 Days of DevOps by Michael Cade. This is a GitHub repo. If you go look it up, and you follow along for 90 days to build out your DevOps skill set if you're a network engineer. So you'll get to learn things like containers and Kubernetes, as well as working with Git, which is what I've been kind of talking about for the last 20 minutes or so, 25 minutes or so. And then if you want some more assistance or guidance, there are other resources that you can go look to. Kubernetes and Networking is an excellent resource by James Strong and Valerie Lancy. It gives you a very pointed view, a very specific view of, how you would start off with nothing and build up to using Kubernetes networking. Then there's Istio in action if you really want to take your layer 7 networking game to another level. And then there's also Solo Academy if you also want a guided approach where you can take live workshops to understand computer networking or microservices networking and even service mesh networking. So with that, I want to say thank you and always follow the packets. If you have any questions, I think there are some in the chat. I'll go ahead and answer them live.
Yeah, thank you, thank you. It was really, I would say like it was funny little, and it was fun having you. Thanks for this talk, and it was really amazing. Your journey was really awesome. So let's take the questions. Cherish, you can go forward.
Sure. Thanks, man. Great presentation. And I really like the lingo that you used. I think kind of sits home. And also, I think you kind of answered one of the questions that they had one of those were, please suggest some courses with labs about BGP and some advanced networking. I think you kind of covered that out pretty well. The next two questions, one of the questions that we have is, hi, Marino, could you please explain a little more about service discovery and service mesh? Thanks.
Yeah, so service discovery is an interesting concept that service mesh does offer. What's interesting is even within Kubernetes, you do have service discovery anyways, so it does exist. But the service discovery is another layer of mechanism to really tell services directly about each other. So what's interesting is, that sidecar resource that goes into the main or to your pod that sits along your main container, that is the entity, or I would say a proxy, that's learning about other services that it needs to communicate with. And this kind of extends beyond, the service discovery mechanism that is present inside of Kubernetes. It actually leverages it as well. But what's interesting is in a service mesh like Istio has to maintain a database of all entries of all the paths that it knows about. So it's going to tell all the proxies how to get to these different paths. It's a more complete path towards that destination. And so that service discovery is not just about knowing who that entity is, it's also about knowing how to get to that entity as well. It then further extends out if you decide to go into a multi-cluster approach where you have a service that lives in one cluster and that needs to talk to a service that lives in another cluster at some other location. Normally, Kubernetes service discovery can't extend out that way. This is where service mesh service discovery can extend out that way as well.
Awesome. Thanks. I think that kind of concludes it. Thanks, Marino, for your time. And I think we're bang on time.
Awesome.
Great. Perfect. Thanks. If any questions come up, please hang around to kind of type them as they come. Yeah.
Yep, I will. I'll hang around for a bit. Thanks, everyone.
Thanks, Marino. Cool. Perfect. Thanks, Rohit, for concluding this. And next we have Avinash. Avinash is a good friend. We go long back, and I think it's very cool to kind of have him again as one of the speakers and discuss building, CI/CD pipelines, which is one of the things of my personal interest. And I think with that, Avinash, we can start. If you have anything to add, we'll start with your introduction as well.